All right, everybody, let's talk about cost, average cost, and marginal average cost. Okay, I should have a hyphen right there. But anyway, so I based what I have here off of something I saw or put on our assignment. And it was some kind of a food vendor, a hot dog vendor, and a cost function was given. The cost of doing business. There's always a cost of doing business. The cost to the vendor for selling X number of hot dogs in hundreds. So C is the cost to the vendor, and X is the number of hot dogs sold in hundreds. So if like real quick, let's do some interpreting. If X is equal to 3, then we say 300. Okay? All right. Or we might say 3, and then you'd have to verbally attach the 100 to it. Okay? In our function, if that's the way we see the numbers, that's the way we got to think about it. Okay, so that's all given. We've got a cost function, define the variables. And let's say part 1 is what is the average cost function, okay? In economics, when we have average anything, we normally put a bar above it. So like if C is the cost of the vendor, then we say C bar, C with a line or a bar above it. C bar is the average cost function. Okay. Well, so what would average cost mean? Like I could say, here I did some calculations in order to get you to think about what the average cost would even be. But if I sell 1,000 hot dogs, when that number is 10, when X is 10, that means 1,000. I have a cost of $1,080. Okay, so but that's just what my cost is. What would you say your cost is on average? Like, well, that would be like $1,080 per 1,000 hot dogs. Okay, so on average, that's how much it's going to cost for 1,000, because 10 means 1,000. Now, I can reduce that. I can divide the 1,080 by 10, and I'll get 108. But that would leave behind that verbal 100, okay? Because remember, if X is 3, that means 300, okay? So, all right, we're walking this through. The cost of selling 1,000 hot dogs is going to be $1,080 divided by 10, or per 1,000. Now I divide the 10 into it, I leave the 100 behind verbally. Okay, so my units are, it's going to cost $108 per 100 hot dogs. On average, it's going to cost $108 per 100 hot dogs. Now let's look and compare with 50. If X is 50, my cost is $4,680. My average is going to be that it costs $4,680 per 100 hot dogs. I can divide the 50, and that will leave us this. It'll cost about $93.60 per 100 hot dog on average. Okay. Why? Now note how the average cost is decreasing. The more hot dogs we sell, the lower the average cost is. The reason for that is because the more hot dogs you sell, the less of a factor the startup cost is, or the fixed cost. Because you could say, like in this formula, 180 is a fixed cost and 90 is a per unit cost. So the more you sell, the less influence the fixed cost has. And that's why generally the average cost goes down over time. Now, there's some numbers, just to think about numbers, because we are doing math, and so I don't want to leave numbers and calculations out of it. But you see how I got the average? I took the cost and I divided it by the number of units. Okay, that's how you do it. 1,080 divided by 10, that's the average cost. Now I had to interpret the number a little bit here and tell you how I left the 100 behind, the verbal 100, when I divided by the 10. But, you know, that's the units, that's the way it works out, okay? Anyway, so let's see, let's get that function. Now I wanted to tell you this so I could give you a way to generate this function. All right, so C bar of X, what did we do? We took the cost, okay? which was 180 minus or plus 90x, and we divided by the number of units sold. That's how each of these was found, all right? And so rather than just tell you that that's what it is, hopefully by thinking about what the word average would mean, it makes some sense that it would be like that, okay? All right, so there is my average cost function. Always just take the cost and divide by the number of units. Now, what if next we get this, part 2, find the marginal average cost function? Okay, well, now when in math or economics we hear the word marginal, then that is referring to a derivative. So if we have cost, the marginal cost would be the derivative of the cost function. If we have revenue, the marginal revenue would be the derivative of the revenue function. You get the idea? If we have profit, the marginal profit will be the derivative of the profit function. Okay, so the marginal average cost would be the derivative of the average cost function. C bar prime. The prime indicates derivative. So I'll take the derivative of this, and in order to find C bar prime, I would have to use the quotient rule. Okay? So the quotient rule, QR for quotient rule, because it's one function divided by another. It's 180 plus 90x divided by x. Okay, so our quotient rule looks like this. If our function c bar of x is one function, we'll call it f, over another function g, then the quotient rule says our derivative is f prime g minus g prime f over g squared. Okay, so there is our quotient rule. What that's going to be for this, okay, f prime, the derivative of 180 plus 90x, that will be just 90. G, that's just x, minus g prime, the derivative of x is 1, times f is 180 plus 90. Okay, and then divide by g squared, which is x squared. All right, now if I reduce this, here's what I'll get. Negative 180 over x squared. Okay, so my marginal average cost function is negative 180 over x squared. Now, let's do some calculations and interpret the numbers we get. All right? So, what calculate and interpret, let's say, C bar prime at 20, which is the marginal average cost at a sales level of 20. Okay? So, see, that's easy to put the number in. C prime bar 20 is negative 180 over 20 squared, which turns out to be negative 0.45. Now, what does the number mean? So what if it's negative 0.45? How do we interpret that in the bigger situation of the food vendor and his cost and average cost of selling X 100 hot dogs? Well, okay. All derivatives can be interpreted the same way. If I have y to be some function of x, then the derivative y prime or f prime of x can be interpreted as the change in y over the change in x. Okay? So, what are the variables here? X, the number of hot dogs sold in hundreds, and C bar, which is the average cost of selling so many 100 hot dogs. So we could think of this as the change I wrote. I'm sorry. That should be a bar right there. Hold on, just a second. That prime should not be there. Okay, so this is the change in the average cost over the change in the sales, units sold. So what units does the average cost have? Well, remember up here when we're doing our calculations, it was in dollars per 100. The average cost in dollars per 100 hot dogs. Okay, so that has units of dollars per 100 hot dogs, and the units of X are just the number of hot dogs sold in hundreds. So you could say that those were the units. Now, we could look at like this. Suppose I put a 1 under that, and I look at if x changes by 1, then the average cost will change by negative 0.45. All right, then we can get our interpretation from that. At a sales level of 2,000, why 2,000? Because this is 2,000. Okay, that's 2,000, 20 times 100. At a sales level of 2,000 hot dogs, if an additional, what's 1 mean in terms of x? 100. If an additional 100 hot dogs are sold, the average cost will decrease by 45 cents per 100. Okay, so the average cost is decreasing. Okay, but you know, if like for 100 sold, we'll find that it decreases by 45 cents. All right, now that's how I want you to interpret any derivative. It's just going to be the change in this variable over the change in that one, even if you have to adjust for the units. Okay, so I hope that ties it all together. I definitely want you to be able to do the calculations. I think the calculations are probably the easy part. More so, I want you to interpret the number. If you're going to study economics and business someday, finance, then we may occasionally use calculus and we get numbers and we need to know what those numbers mean. All right, so that's why I think, you know, perhaps this be the most important part of the problem, because calculations aren't really the hard part most of the time, especially if you have a calculator. You can even get some calculators will find the derivative for you, right? But they may not be able to interpret it, and that's what I want you to be able to do.